Hey guys, welcome back to my channel and I'm back again with another really interesting coding interview question video. This time guys, we are going to solve question number 993, cousins in binary tree. Before I start with the video guys, just want to request you that if you have not yet subscribed to my channel, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. Let's get started now with the problem statement. So basically guys, we are given a root of a binary tree and the binary tree has unique values, and now we are given two variables here with the binary tree x and y, and we want to return true if the x and y are cousins of each other, and we have to return false if they are not cousins of each other. And the first thing is we want to determine what's a cousin. So you can see here that a cousin, two nodes are a cousin only if they are on the same depth of a binary tree and they don't have the same parent. Okay, because if they have the same parent, that means they are siblings, they are not cousins, right? So in this case, x value is 4 and y value is 3. So you can see that 4 is the child of node 2 and 3 is the child of node 1. So basically they are not on the same depth, hence they cannot be cousins. So the answer is false. Now in the second example, you can see that we have got x5 and y4. Now you can clearly see that 5 and 4 both are on the same level, but both are having different parents. So that's why they both are cousins and hence the output is true. There are a few more examples guys which are similar to this. Let's jump to the constraints. The number of nodes in the tree is in the range from 2 to 100. Every value goes from 1 to 100. Each node has a unique value, and obviously x is not equals to y. So they always have to be cousins or siblings or something like that. They are not equal to each other. And x and y both exist in the tree. Okay. So that is the problem statement guys. I hope it is clear to you. Let's jump to the solution part. Now some of you may have already guessed it that the way we are going to solve this problem is going to be level order traversal. So this level order traversal is sort of a BFS or breadth first search approach, where we actually traverse through the entire breadth of a particular level to find out our results, and then we go to the next level. Okay, so this is how we are going to solve this problem. Let's jump to the coding part of it. So the first thing which we are going to do guys is we are going to declare two boolean variables, and these boolean variables are going to determine if x and y both exist as a cousin or not. So if x exists in the same level, I'm going to store it in x exists, and by default it is going to be false. And then there is going to be another variable called as y exists, which is also going to be false. The both values are going to be true only if x and y both exist on the same level. Okay, now next thing, if root is equals to null. Obviously guys, if root node is equals to null, simply return false here, because we know that if there is no root node, then x and y both cannot exist. Now for level order traversal, we always maintain two queues. One is going to be the main queue, which is going to store my current node. So the current level node is going to be my inside my queue, which is the variable queue here. And then let me just quickly create this one, and then there is going to be another queue which is called as sub queue, which is going to store all the nodes of the child level. Okay, so let's say the main queue, the queue variable is going to store, let's say, the root node. Then the sub queue is going to store all the children node of the current node. So basically sub queue is the next level and queue is the current level. Okay, now initially, because we know that root node is not equals to null, so simply just add root in our main queue, and now we can start traversing. So while queue is not empty, so I'm just going to add not here and then start with the while loop. So the first thing which we are going to do is we are going to poll the queue to find out the current node inside the queue. So queue.poll is how you can use it. Then we are going to check if the current node value is equals to x. If the current node value is equals to x, it means that the x exists in the current level. So I'm just gonna make x exist to true. And the same thing I'm going to do for that if at the current level y value is also present, or if y value is present, then simply say y exists equals to true. Now let's say I am at the current level and I am at currently, let's say, at this level or at some of the level, and I have found that both x and y exist. That means at the same level I have found both x and y. So then it means that my purpose is solved. So I can simply return true from this while loop and I don't have to process any further nodes. Okay, that's how you can improve the complexity. But let's say this hasn't occurred. So then I have to process the children node. So tree node left becomes equals to node dot left. And then I'm going to declare another variable, tree node right becomes equals to node dot right. Now, if you remember, the condition is that the cousins cannot be siblings, right? So these x and y values cannot have the same parent. So this left node and this right node is having the same parent, which is node, right? Sorry, I have to rename it to cur because I am using cur everywhere. So let's rename this to cur. So both left and right node are having the same parent, which is cur, right? Current node. So if both left and right values are either equals to x or either equals to y, it means that these are not, x and y are not cousins, they are siblings, so we have to return false. So now we are going to check that. So if left is not equals to null and left dot val is either equals to x or left dot val is either equals to y, it means that the left node is either equals to x or y. So it is one of the nodes to be found. And then I'm going to check the same thing with right node. So if right is also not equals to null and right dot value is either equals to x or right dot value is either equals to y, basically means that the x and y are siblings, not cousins. Okay. So in this case, what we are going to do? We are going to return false. So we are not going to process any further nodes. We will return false from here only. If there is no such condition, if they are not siblings, then we can simply do the simple level order traversal, that if left is not equals to null, then add left in the subqueue, left, and if right is not equals to null, then add right in the subqueue. Okay. Now, in the level order traversal, once you have traversed all the nodes in a particular level, then in your current level, then your queue will become empty, right? So at this point of time, your queue dot is empty function is going to return true, right? So if your queue becomes empty and your sub queue is not empty, that means there are still nodes to be traversed in the next level, then we are going to simply assign this sub queue to my current queue, right? But obviously guys, we are only going to do this if we have not found our x and y. Okay. So actually no. Okay. So if x and y are found, then we are already returning true from here. So then in that case, we will not jump into this condition. But if either x is not found or either y is not found, then we will go to this condition and we will simply reset the x exist and y exist value to false again, because now we are in the next level. So we have to make sure that in the next level both x and y should be found, right? I mean, this can be the case that x is found in this level and y is found in this level, so we are returning true. No, that's not the case. So if you have jumped into the next level, if you are processing the sub queue now, you have to reset the x exist and y exist value to false, so that you can immediately determine if both x and y actually exist in the same level. And then queue dot add all sub q. So simply you are assigning the sub q to q, and sub q becomes equals to a new linked list, so that you can process the further nodes in the next level. So now that this while loop is completed, you can simply return x exists and y exists. If both x and y exist and you didn't return from here, then you can simply return x exists and y exist value. If both are true, it means they are cousins. If any of them is false, it means they are not cousins. So let's run this code, guys. Let's see if this works. And you can see that it is getting accepted for one test case. And hopefully, yeah, you can see that it is now accepted for other test cases as well. So now let's talk about the time complexity, guys. So the time complexity for this solution is going to be order of n, because again we are traversing all the nodes. Let's say if my x and y, they both exist in the last level, so in that case I would have traversed all the nodes once. So that's why the time complexity is order of n. Now the space complexity is also order of n, because as you can see here, we have maintaining two queues, and one queue is having certain nodes at a particular time, and another sub queue is having certain nodes at a particular time. So if we are assuming that we are having half of the nodes in queue and half in sub queue, then again the space complexity will become equals to order of n. Okay. So that was the solution, guys, and I hope this solution was clear enough for you, and I hope your coding practice became a little bit better. If it did help you guys, then please do not forget to like this video and share this video with your friends. Again, I want to request you to subscribe to my channel and hit the bell icon for future notifications. If you have any questions, comments, suggestions, any better solutions for the same problem, please do not hesitate to write in the comment section below. Everybody is going to benefit from that. Thank you so much for watching, guys. I will see you guys in the next video. Until then, take care and bye bye.